You're watching Code Like an Architect series with Adil Ata on ArchiWisdom. Suppose there is a hospital. In hospital, there are doctors. Doctors have assistants. The hospital announces a new service. Call your doctor. When patients came to know about this new service, they reached out to assistants asking them how they can call their doctors. When patients reached out Assistant 1, she gave everyone the direct contact number of the doctor. On the other hand, when patients reached out Assistant 2, she gave everyone her own number. And whenever she received a call, she would forward the call to the doctor while keeping the doctor's contact information hidden. In the next general meeting, doctors complained that they keep receiving the calls from the patients all the time. Day, night, weekend, weekdays, during a clinic, during a surgery. In the end, it was decided that from now onwards, doctors will receive call only on weekdays, from 1 to 5 if there is no ongoing surgery or clinic. But in case of Assistant 1, she has no control over this. She sent a message to all the patients informing them about the new timings to call. But the patients still kept calling the doctor at any time. In the end, all she could do is to ask the doctor to change his number, which is an inconvenience to the doctor as well as the patients. On the other hand, in case of Assistant 2, she will keep receiving the calls the same way she used to do. To implement the change, all she has to do is to add an extra if check in terms of programming. Whenever she receives a call, she will check if this is the right time to call the doctor, specifically if the time is between 1 to 5 and there is no ongoing surgery or clinic. If yes, she will forward the call to the doctor. Otherwise, she will educate the patients about the right protocol to call the doctor. Now, what's the difference? What Assistant 2 has done correctly that Assistant 1 missed? The answer is data hiding. The Assistant 1 wasn't hiding the doctor's contact information, hence she lost her control. And when a change was required, she has no control over this. She had to cause herself and everyone a lot of inconvenience. On the other hand, Assistant 2 was hiding the data. In that case, doctor's contact information. By hiding data, she has all the control. When she needed to accommodate a change, all she had to do was perform an additional check. That's it. That's the power of data hiding. By hiding, we keep the control in our own hands, which empowers us to accommodate future changes seamlessly. And this improves maintainability. Similarly, a class hides its data from other classes by making it private so that it keeps control over things. And when a change is required, we can apply that change by changing a single class rather than many classes. Hence, the code remains maintainable. Now see this code. This is a class student with following data attributes. Note that all of its data attributes are public. We are using this class on many places in the code base. This code is up and running. Now there is a change. We have to fix a bug and incorporate a change related to date of birth field. We have observed that there are so many records in the system that have future dates set in the date of birth column, which later causes problems. We need to add a validation to avoid this. Also, we have to add a new field, age. But we won't take the value directly as input. Instead, we will auto-calculate the age based on date of birth. To do this, we need to add a validation before setting date of birth and calculate age after setting date of birth. But the problem is, we will have to do this in all the places where we are setting the date of birth attribute. Question: do you know on how many places are we setting the date of birth field? The answer is, we don't know. Depending on the size of the code base and the attribute we are dealing with, this could be any number. It could be 10, it could be 100, it could be 1000. Even if we check all the references, it's not a good programming practice and experience to apply the change in all the places. We could have avoided this situation by hiding the data like this. We will hide the date of birth field by making it private and then expose a public method, set date of birth. Since the date of birth field is private, we know that no one can directly set this. Any code that needs to set date of birth will be forced to use the set date of birth method, like this. Now we are in full control. To apply those new changes, all we need to do is this on just one place, and the change would reflect everywhere automatically. We don't need to apply the change everywhere like we did before. That's how a class keeps control in its own hands by hiding its data, which helps in maintainability phase. How this works? When a class makes the data attributes public, it loses the control because it cannot intervene in data assignment calls. But by making the data attribute private, we block the direct access on data. And by exposing a public method for setting a data, we know that any code that needs to set this attribute will take this path. Through this setup, a class creates room for itself to intervene and make any changes when needed. Since you can easily make changes in a method at any time without needing to make any changes in the calling code, this setting keeps the class in charge of making any future changes without changing any other class. That's how it works. Now think of any scenario. You wanted to validate for future dates? We already did this. You may have some other age restrictions for your students. Here you are. You want to notify other classes whenever this field is changed, which is a very common scenario in UI. That's how you can do it. See how seamlessly we are accommodating the changes, and the code everywhere else remains the same. Just like we have this set date of birth method, we can also have a get date of birth method. These are called setters and getters. Think of more scenarios. You may need more computed fields. You may need to add caching or lazy loading later, and so on. By hiding data, you are in full control of making any changes. This is data hiding, which we achieve through encapsulation. What's the difference between encapsulation and data hiding? Encapsulation is a broader concept, while data hiding is an application of it. I already have a video that explains the core concept of encapsulation in the same series. You can find the link in the description. Encapsulate means to enclose, to encase, to envelop. If you think about it, it also implies hiding. When you enclose or envelop something, you actually hide it. That's what we did here. We are keeping the data hidden by enclosing or encapsulating it in a class. We achieve data hiding through encapsulation to improve maintainability. The role of access modifiers. Notice what we have basically done here. We have simply set some restrictions. That's it. Number 1, don't use the attribute directly to access the data. Number 2, instead, use a method to do this. That's it. But rather than leaving this on a general understanding of every developer, we have enforced this decision by using access modifiers. We made the data attribute private and the method public. As long as this field is private, we can guarantee that no code outside this class is modifying this data. That's how we enforce and ensure encapsulation using access modifiers. At this point, if you remember the mindset that I talked about in one of my previous videos about how we use the tool set or feature set of a language to carefully design each detail of an object. Note that access modifiers is one of our tools or feature. We are using them in this particular scenario to enforce encapsulation so that we can improve maintainability. Properties. That's how we achieve data hiding through encapsulation. Question. How would we know which attributes are going to need such changes in the future and which aren't, so that for the ones that will change in the future, we will hide them? Of course, there is no way to reliably predict such changes. Therefore, it is recommended that we always hide the data and use getters and setters for all attributes as a general practice, like this. But then there's a problem. We are going to require 2 additional methods for every single attribute. So if we have 10 attributes, we are going to need 20 additional methods, which is a lot of work. That's where properties come into the play. Many languages like C# provide a built-in spatialized construct to handle this situation. Properties is a spatialized construct which gives an attribute-like experience, which means we don't have to put any additional development efforts up front. We use properties just like we use data attributes. However, inside properties, we have built-in getter and setter methods. So whenever needed, we can customize the implementation of getters and setters and be in control without putting any upfront development efforts. Wait a minute. Wasn't that related to security? Watch the next video.